I've always thought that practical work was an important part of physics, and so in this video I will concentrate on what I might call experimental technique, and I will refer to the experiment we did with the rubber band. So first of all, read your instruction sheet carefully and completely, if there is one, or if there isn't, plan your experiment fully and write down what you intend to do. Assess any risks that you might think of for the experiment. Collect and check your apparatus and make sure you know how to use it. This is especially true where the experiment involves electrical circuits. Next, set up the apparatus as directed or planned, and if asked, check with your teacher before you start the experiment. Plan the range and the number of readings and spread your readings equally across this range, but don't set your readings to particular numbers. For example, don't decide to take readings at 10, 20, 30, 40 degrees centigrade, not exact values, but simply spread them out equally. Next, take the readings carefully and to a sensible degree of accuracy using the correct scales. Now, this means that there is no point in taking readings of one variable to an accuracy of 1% if other variables will have an accuracy of only 10%. Allow for parallax. Now, this is parallax here. It means that you need to put your scale close to the object you're trying to measure, because if you move the scale away and then you move your head, then the apparent reading is going to change. Repeat readings if you can do this, and then take an average. Don't rush. Nothing worse than a hurried experiment. Write your results in a fully labelled table with headed columns with the quantity and the units. And then carry out a calculation if one is asked for. Plot a graph. Now, this is what we did for the rubber band experiment, so I'm going to show you a separate sheet on what I think you should do when you plot a graph. First of all, give your graph a title. Choose a sensible scale for both axes that fits the paper, and try and draw a graph that will fill the graph paper that you have available. Label the axes not only with the quantity but with the unit that you've got. Plot the points correctly. This may seem obvious, but I have seen many people that haven't done that. Mark the points clearly with a plus or a dot. Draw a smooth best fit line through the points. Now, a best fit line is often called a trend line. It shows the general trend, but you don't have to join up all the points. In fact, you should not do this unless they actually fit the trend line. Recognize any anomalous points, that is, ones that are way off the general trend line, and attempt to explain them. Also, if you can do this, try and repeat them to check whether they are indeed anomalous or whether you've discovered something vital in this slight variation from the expected line. Draw the line clearly and finely. And on the back, I hope I've done this for our experiment, because this is a graph of the results that we obtained for the stretching of the rubber band. See, it's a beautiful line, and I haven't joined all the points together. And to explain the bottom part, of course, it was where the rubber band at the beginning, because it only had the little pot hanging on it, was actually not extending linearly like it is up here. Identify any errors and difficulties in your experiment and suggest how to explain them and reduce them, and maybe suggest an alternative experiment to measure the same quantity. End with a conclusion. This should be numerical if required, and make sure this conclusion has a suggested accuracy with the correct units. It must be to, in fact, give you the answer to the aim of your experiment.